Hello, Math 9. Welcome back, and we're doing assignment number 8 today. It's on scale diagrams. Got a little picture for you I found on the internet. Gives you a sense of scale diagrams by showing you what isn't a scale diagram, right? This drawing is not to scale. You understand why? Because look at this house, the real house, and then this person's tried to draw this house. Why is it not to scale? Because this house is way skinnier than that house. It should look exactly the same. So this definitely, what we're doing today, relates to what we've done the last few lessons, relates to scale factors, and it also relates to changing units, as you'll soon see. It kind of brings both those topics together into one. So here we go. I've sent you these notes. If you want to use them, you can print them off or whatever, but this is not the homework, remember. This is just for the notes in the video. So scale diagram. What is a scale diagram? It's used to draw an object when it's unrealistic to draw its actual size. So think about someone who is making blueprints, or an architect or construction plans, an engineer, and they're not going to draw the plans on a piece of paper that are the same size as an actual house. So they draw it smaller, obviously, on a piece of paper, but they draw everything to scale. They don't do like this person did, the mistake, and draw it way skinnier on the picture than it is in real life. Everything has to be to scale. Um, it has a scale. It has a scale factor. We often just call it the scale, but it's also referred to as the scale factor, just like we learned before. And just like what we learned before, the way you find the scale or the scale factor is you take the length of the drawing and you divide it by the length of the actual object. Because remember, when we did the scale factor formula before, we did something like the new divided by the original. And you can see that relates, right? The original is like the actual, the real object. And then the new is the drawing, the facsimile, the replication of that original object. So hopefully that makes sense, that basically what we're doing today is just an extension of scale factor, which we already learned. All right, a couple other things to say about scale diagrams. To find scale, if we want to find out what the scale or the scale factor is, we need to do two things. We need to write each term of the ratio in the same units, and we need to put it in lowest terms. Now, this isn't always true, actually, to tell you the truth. Think about on a map, like in the bottom corner of a map, sometimes you'll see something that looks like this. This is the scale. And the way you do this is you take a ruler or something and you could measure, for example, from here to here. Why don't I use a different color? From here to here, and you'd measure it with a ruler. And let's say that that amount there was 1 inch, just to make it easy. Let's say you measured that with a ruler and it was 1 inch. Then your scale is 1 inch is equal to 300 kilometers. And you can see you have different units there. So that way, if you took your ruler and you measured on the map, here's one city, here's LA, and here's another city, here's Chicago, whoa, I don't even know what that says. And you measure it and you find that they are 7 inches apart. Well, then you could say, well, if 1 inch is 300, then 7 inches would be 300 times 7, 2,100 kilometers. So those cities are 2,100 kilometers apart. Anyway, my point is that you can have a scale that has different units, right? We have inches and we have kilometers. But you'll see other type of units that look like this. So they say 1 to 25,000, for example. So there's no units at all in this one. And what that means is if you measure on your map, let's say you measure two objects are 1 centimeter apart on the map, then they'd be 25,000 centimeters apart from each other in real life. Or if you measured that two things were 1 decimeter apart on the map, then they would be 25,000 decimeters apart from each other in real life. And if it was a really, really big map and it was 1 meter apart from each other on a map, they'd be 25,000 meters apart from each other in real life. So this is what I'm talking about. If I go way back here, this is what I'm talking about when I say that scale factors should have each term with the same units. Those are the type of scales we're going to be using here. All right, sorry, kind of a big tangent there. And the second thing that needs to be true is that it should be in lowest terms. So you would never have your scale, you'd never see on a map something that says, oh, the scale is 2 to 400. No. If you figured out it was 2 to 400, you would put it in lowest terms. And obviously you could divide them both by 2 and get 1 to 200. So you're going to make sure it's in lowest terms. All right, let's do a few questions, and I think this will all start making sense. These questions are very similar to the ones that are in your book. So if you understand these, your homework assignment will be fine. It says, if the length of an animal is 10 centimeters on a drawing and the scale is 1 to 60, find the actual length of the animal. So what we're going to use over and over here is the scale formula. And remember we said that scale, I wrote it right up here, I'll just remind you, right here. Scale is the length of the drawing divided by the length of the actual object. So I'm just going to put that scale equals drawing divided by real, right? The actual or the real one. So what do we got here? Do we have the scale? Sometimes you'll have the scale. And I do see the scale. It's 1 to 60 right there. So instead of putting scale, I'm going to put 1 to 60. I'm going to put 1 to 60. Well, wait a minute. I don't want to write it that way. What's a better way to write 1 to 60 than like that? Write it as a fraction, right? Don't write it in that ratio form. Write it like this. Why is that going to be helpful? Because you can bet we're going to do good old cross multiplying. You could get through this whole course, Math 9, only knowing how to cross multiply, right? It's like the most important skill in this whole course. Okay, so we have gotten rid of this ratio. We've used that. We have one other number here, this 10 centimeters. Is that from the drawing or is that from the real life? If the length of an animal is 10 centimeters on a drawing, oh, the 10 centimeters is the drawing. So where it says drawing, I should put 10 centimeters. And what I want to know is I want to know what's the actual length? What's the real length? So this is the thing I don't know. I'm going to call it m, I suppose. And we got to figure out how much that is. So we're going to cross multiply here. I'm going to go 60 times 10 and divide it by 1. Well, dividing by 1 does nothing. So really all I have to do is 60 times 10 centimeters. I'll put the divide by 1. And if I do that, 60 times 10 is 600. Divide by 1 is still 600. 600 what? Well, remember this had no units here. So if it's centimeters there, guess what it's going to be down here? Centimeters as well. Darn, maybe I shouldn't have used m. You might think I mean meters or something. I'm going to switch it to x. I'm sorry. Okay, let's say it's x and x, just so you don't get confused. That doesn't mean meters. That just means unknown amount. And since it says centimeters here, it's going to be centimeters here. Now, what do you think of that answer? The length of the animal is 600 centimeters. It's not wrong. It's not often you'd say to someone, oh, look at that animal over there. It's 600 centimeters long. You'd probably put it into what unit? Meters. So here's what you got to remember from last day. How do you switch 600 centimeters into meters? Remember how to do this? We do this method that Miss Hughes is going to love you for knowing next year in chemistry, or in Science 10, I suppose. You're going to take 600 centimeters, you're going to multiply. You want to get rid of the centimeters, so we're going to put it on the bottom, and we want to change it into meters. And now all you need to know is, what is the relationship between meters and centimeters? So this is one of the things you need to memorize or write down or whatever. You should know that 1 meter equals 100 centimeters. So the 1 goes with the meters, the 100 goes with the centimeters, and we're ready to get our answer. How do we do it? Well, first of all, the centimeters are going to cancel. We got 1 on the top, 1 on the bottom. Ninja slice those. So we're going to be left with meters. That's perfect. That's what we want. And when you go 600 times 1, you still have 600. Divided by 100, 600 divided by 100 is 6. Now, I know some of you didn't need to go through all that. You knew right away this was 6 meters. But I just wanted to show you that what you'd learned last time is going to be useful again today. So this answer, correct. This answer, definitely better. And if you were checking an answer key, I'm sure they would have this as your answer. So be ready to switch into an appropriate type of unit. Okay, that's when you're finding the actual length. What if you're trying to find the length of a drawing? I think in this one, yeah, how big is the drawing? So talking about ladybugs here. Actual size of a ladybug is 2.5 centimeters. I just made this up. It might be completely wrong. If Tim draws a picture of the ladybug and uses a scale of 5 to 1, then how big is his drawing? All right, so remember our formula. Scale equals drawing over real. Remember, drawing could also be a model, could be, I don't know, a map, whatever. So, do we know the scale? Sure do. It's 5 to 1. Don't write it like that though. Write it 5 over 1. What other number do we have? This, 2.5 centimeters. Is that the real size of the ladybug or the drawing size? That's the actual size. So where it says real, you're going to put 2.5 and 2.5 centimeters. So once again, our answer is going to be in centimeters when we get it. We want to know this one here. I'll call it y. I think that's safe. Okay, so we cross multiply to get y. We go 5 times 2.5. We divide by 1. I'll make it a times. Divide by 1 won't do anything. So when you do that, you're going to get 12.5 centimeters. The drawing's 12.5 centimeters. What do you think? Is that a good unit to put it in? I think so. You wouldn't want to change it to meters. You could change it to millimeters, I suppose, but I think this is a very good answer. So I don't think it's necessary to switch the units this time. Okay, now we're going to write some units. We're going to write some scales, and we're going to write them as a ratio, right? They're going to look like, for example, this one we had 5 to 1, or in the previous one we had 1 to 60, or in this one, there's an example of a scale. You want it written like that. So, first question. 4 centimeters represents 28 centimeters. So you can start right away by making it a ratio. Now, there's two things that have to be true. One, they need to have the same units. So in this case, we have centimeters and we have centimeters. Hey, that's great. They have the same units. You know what you can do if they have the same units? Get rid of them. 4 to 28 can now be our ratio. So what this means is not only does 4 centimeters represent 28 centimeters, but 4 meters also represents 4 meters, and 4 kilometers represents 28 kilometers. So we can just put 4 to 28, and that'll show that 4 of any unit represents 28 of any of the same unit. So that's good. All right, so that was one step, get the same units. Second step, needs to be in lowest terms. This is not in lowest terms, right? We could divide them both by 4. 4 divided by 4 is 1. 28 divided by 4 is 7. We are done. That is our scale as a ratio in lowest terms. Okay, let's try another one. 12 millimeters represents 6 meters. So we can put 12 millimeters and 6 meters. Uh-oh, we have a problem here. The problem is that we have different units. So there's a couple things you could do. You could switch your millimeters into meters. You could switch your meters into millimeters. Or you could switch both of them into something if you want to switch them both into centimeters or something like that. I think it's probably easiest if you switch them both to millimeters. So in other words, I would keep this one as millimeters. And I would figure out how many millimeters is 6 meters. Okay, well if you need to, you might not. But if you need to, let's do this method, the Hughes method. Miss Hughes's method. It's not only her method. It's used a lot in science. Let's use this method to switch our millimeters to switch our meters to millimeters. Sorry about that. So we're starting with meters and we want to switch it to millimeters. So the one we want to get rid of, the meters, we put in the bottom. We want to switch it to millimeters, and then you got to think, what's the relationship between meters and millimeters? So again, there's about 3 or 4 of them you need to memorize, and this is one of them. 1 meter equals 1,000 millimeters. So the 1 meter, 1,000 millimeters, 1,000 millimeters. You can cross off the meters, so you're going to be left with millimeters. Dividing by 1 is great because you don't have to do anything. So all you have to do is multiply 6 times 1,000, and if you do that, you will get 6,000 millimeters. Great, we have the same units now. Once you have the same units, you don't need to write them anymore. 12 to 6,000. Right? If 12 millimeters equals 6,000 millimeters, then 12 kilometers equals 6,000 kilometers. 12 decimeters equals 6,000 decimeters. 12 whatever micrometers equals 6,000 micrometers. It really doesn't make a difference. Are we done? No, we need to put it in lowest terms. All right, can you do it in one go? Maybe you can. Maybe you can't do it in one go. That's fine. What could you divide both of these by for sure? Well, they're both even. I could divide them both by 2. So 6 to 3,000. I could still divide them by 2. 3 to 1,500. Now, hopefully you recognize you could divide them both by 3. 1 to 500. Of course, you could have gone straight from here to here. If you divided them both by 12, you would have gotten the exact same answer. So this is the ratio that we're interested in now. Okay, and that is scale and scale diagrams. So your homework assignment, this is assignment number 8. It is due on Monday, May the 11th, of course, at 3 p.m. It will be in your workbook. It is on page 165 to 166, and it's numbers 1 to 5. Okay? Looking ahead, next week I'll give you 2 assignments, of course. One will be a review of everything we've done so far on this online learning, and then the second assignment next week will be a quiz. This will be your second quiz, I believe. And then we'll be done with this chapter, and we'll move on to something else. Okay, as always, let me know if you're not understanding anything. Good luck, and thanks to everyone who's handling in work. I really appreciate that this is a hard situation, and I appreciate all your efforts. Take care. Bye.